Hello, and welcome to this partner session on Nordic Circular Summit. My name is Stian Bergeland, and I'm the coordinator of the Nordic Council of Ministers Working Group for Circular Economy, NCE for short. We are proud to host this event. NCE is a network of government agency experts working on issues related to circular economy. Our mandate is to facilitate exchange of information between the Nordic countries and to develop and disseminate information that can be used in the transition to circular economy in the Nordics. We produced a lot of reports and knowledge in the past few years, and all our reports are available for free on norden.org. I will now show you links that you can also go to our website and look further into our reports. Today we will deep dive into some of the topics that we are currently considering central to circular economy. The starting point for the session today is 3 projects that we are and have carried out during the past year. The common denominator is that they propose important changes in the handling of resources and prevention of waste. First, we will hear from Susanna Seppälä from Sweco. She is leading our current project on waste prevention, particularly looking into how financial measures can be implemented to nudge us into more circular use of textiles. This is a brand new, the report hasn't been published yet, but Sweco can already now reveal some findings that they will publish later on. One important insight is that the transformation to a more circular textile industry cannot be solved by one single measure. You need a set of stimulus instruments, including regulations and voluntary initiatives, to be successful. We will then take a jump to look at what can be done to prevent products with the valuable raw materials becoming waste, and when waste, how to recycle it. In this context, with valuable we mean critical as defined by EU's Critical Raw Materials Act. The act is based on the need for Europe to become less dependent on external markets for raw materials that are considered important for European industry and self-sufficiency. However, the Act also recognizes that circularity is an important tool to gain self-sufficiency, and bilateral environmental advisors have studied how the Nordic countries can contribute to improve European recycling of waste with high content of critical raw materials, and how we can avoid these products becoming waste in the first place. Carl Christensen will present the project. This is also a new project that is still ongoing. The first, there will be 3 reports. The first one is now available, but the 2 will come later in the year or early next year. Then we will go into a bit of a nitty-gritty on critical raw materials. We will look at printed circuit boards, which is one product containing a lot of critical raw materials. They will present the report Eco-Design Requirements for Circularity of Servers and Data Storage Products. With such a strong interest in data storage centers, the report is very timely and provide recommendations on how to reuse and recycle data server components. Matthias Herman from Viggo Mogge, the authors of the report, will present for us. So that's the outline of today. Before I give the microphone to the first speaker, I will inform you that it will be possible to ask questions to the speakers. You do that by using the chat panel on the right-hand side of your screen. I think it is. We will then ask the questions for you, for the presenters. So we will start the session now. Susanna Seppälä is Senior Manager at Sweco Finland. She's the manager for a project commissioned by us in NCE on waste prevention, as mentioned. The project is just about to be finalized, and the report, I guess as the name Susanna, what policies and measures are needed to prevent waste production and promote reuse. It will be published in December this year or early January next year. Well, I have to wait a bit for the concrete written recommendations. Susanna will now give you a little bit of insight into the report. So, Susanna, the floor is yours.
Thank you, Stian. I'm very happy to be here. today to talk about a very important topic that we have been studied with our colleagues across the Nordic countries for the past 1.5 years at least, how we can use circular economy more effectively to try to solve our time's big challenges of biodiversity loss and climate change, and what role waste prevention plays in the circular economy of the future. So basically, we are looking into how to change our waste challenges of today into a functioning circular economy of tomorrow. And in order to do that, we will need to make a radical shift, both in policies and practices, in how we think about waste prevention, and extend the focus in waste prevention from very recycling targeted policies and actions, which are still also extremely important, to the earlier stages of the life cycle of different materials and products, and look at the whole value chains and the value networks of the circular economy. So we need to put more focus than today on different strategies of refusing, how to make products redundant, how to make new ownerships possible for products through different kind of product service models that have also been discussed today in another session organized. We will need to look at how to reduce the use of resources by making manufacturing more efficient through, for example, digitalization and AI and automation. We need to look at our consumption part on how to change our ways of looking at consumption from ownership to extending the use of what we already have by different strategies of reusing, repairing, refurbishing products, so that we won't have so much to recirculate. And then, of course, we still need to look at how to make sure that we can efficiently take care of the materials when they come to the end of their lifespan. The good news is that we already have a lot of good practices in place in the Nordic region. In the first part of our work, we made a mapping of different good practices from different Nordic countries, other European countries, to look at what kind of initiatives, what kind of measures are already in place. And we found a lot of very different interesting things that are already being done. We collected around 50 different measures and actions, spanning from, for example, material efficiency commitments made by the industry and the public sector together, where different sectors make commitments to try to be more resource efficient and take better care of the material stream. There are a lot of different things that are done, for example, by food industry. We have different ways of trying to label, for example, products that are near expiration, to try consumers that even though something is best before, it might still be possible to use. There are different kind of digital platforms that are used to make sure that so little as possible can be will be thrown into waste. Again, in the restaurant business, there are two Good to Go apps where consumers can buy cheaper food items at the end of the day. We have different kind of second-hand platforms for private persons and companies where you can sell or swap or share your items. And there are different kinds of way of trying to also move the principles of different kind of recycling, municipal recycling stations into a reuse station way. And for example, in Stockholm, there are kind of pop-up reuse stations that can be circulated in the town and where people can leave their products and get products from others. And this is all very good and very needed. The problem is that most of these actions are still voluntary based, and many of them are grassroots actions, and they are kind of separate actions and not so very much tied to the strategies. So we need better policies. So in our work, we also went through the waste handling plans of the Nordic countries and the waste policies, and we found a lot of good development to be continued. We see that there is the significance of waste prevention in the waste plans is rising, both on EU level and also in the Nordic countries. There is an increased pressure for better solutions through EU regulation that is coming all the time with extended producer responsibility and the different directives paving the way towards the circular economy. And the strategies are also more looking into waste prevention actions. But there is still a lot of need for improvement. We need to extend the focus from recycling more into the reuse phase. We need to try to fast track easy and effective policy measures, not wait too long, not wait till we have all the evidence what will be working and what will not be working. We need to test and pilot steering instruments more boldly, and we think that the Nordic region is a good arena to do this. So we continue to be looking into the tools. One of the big challenges that was also raised at the Nordic Circular Summit in various speeches yesterday was that there are not so many economic tools that will drive waste prevention policies in the right direction and circular economy. So we have the regulation we have the policies in place. The economic measures are lagging behind. They are designed for a linear economy and they do not support the development of circular business models. We use the textile sector as an interesting case, since we all know that the textile sector is one that is battling with huge challenges on how to prevent waste and promote reuse. And we looked at 4 different economic instruments that have been tested and are tested in different countries, and that could be potential for the Nordic region. So we looked into the French initiative with targeted fees for fast fashion that is connected to France's own producer responsibility scheme that has been in place for many years, in contradiction to the Nordic countries and most of the other EU countries where these schemes are just being developed. And they're they have been able to try to tie different economic instruments to the implementation of this. And that is mainly an economic instrument that is very much related to fees and bans, where you try to punish producers and importers of unsustainable items. We also looked at other more carrots initiatives that would incentivize the environment towards more circular businesses. So we looked at different funding for developing new business models, and these of models are in place in all the Nordic countries. We have very strong tradition with innovation funding agencies and other public funding that helps businesses to develop better business models. But we also saw that there is still a need for continuing this support, and that there also still are challenges among the businesses. And we looked at different of subsidies for the consumer market. For example, could it be possible to differentiate the VAT for second-hand products, or have different kinds of VAT and voucher systems for repair services in the markets? And we found that even though none of these instruments on its own can help solve all the challenges and will not provide a silver bullet into moving into circular practices, they all have a role to play in the development, and when implemented in combination, they could have potential for making an impact. So our key takeaways that will be more elaborated in our forthcoming report is that we will need to combine different kinds of policy tools in a much more systematic way that has been done so far, in order to make an effective enough shift into circularity. We need to revise the strategies. We need to aim high, but at the same time start with easy steps, because it's better to do something than just wait and for the world to become ready for new action. We need to have foresight and anticipate and be part of making the change. We need to design feasible policy toolboxes where regulatory measure, economic measure, different of voluntary measures and information measures are combined. And we need to provide a consistent messages also from the governments, keeping in mind that information steering is effective and essential for helping behavioral change, and economic tools can be strong signals of political will. Thank you.
Thank you, Susanna. We'll do the presentation. I don't know exactly what happened here now, but can we get up again? There, yes. All right, we'll leave it like that. There are no questions to Susanna yet, but please, if you have anything to add or want to ask your question, we still have time. You can take Susanna up again here. We're looking forward to the report, Susanna. Teaser now, but not too much either, right? Because we're such an interesting topic, and particularly we have discussions about VAT on repairs, for instance. Does it work? Does it not work? So you don't have to say what you think here now, but we'll probably see something about it in the report. Thank you. Then we will move on to the next presentation. Prevention of products with a high content of critical materials ending up as waste is our segue to the next component of this program. As I mentioned, a stable and self-sufficient access to raw materials critical for the competitiveness of European industry and necessary for the Green Deal prompted EU to ratify the Critical Raw Materials Act. I think it was last year or early this year. One component of its success in access to these materials is closely linked to circular principles. They have a whole article in the Act dedicated to how circular economy can contribute to reaching the goals of self-sufficiency. NC has researched how the Nordic region can contribute to the EU goals. Earlier this year, we launched the first, together with Nordic Innovation, in a series of 3 reports highlighting the issue of recycling of critical raw materials in the Nordics. Now, there were 2 subsequent reports published in December or January, so this is also a teaser that you will get here from us. The second will be an in-depth report on recycling based on the first report, and it will provide specific measures that the government may take. The third report will also contain specific recommendations, but will focus more on reuse and other aspects of circularity. Carl Christensen is the project manager for the report from Bergfall Environmental Advisors, and he will tell you more. Although I assume he won't be able to tell you everything in the short time that he has. So Carl, please, let me hear.
Thank you, Stian. Let's see if I can get my presentation. Yeah, perfect. Every day we eat foods, we surround ourselves with materials that keep us warm and sheltered. We travel by vehicles and we use countless tools and technical applications made by critical raw materials. Raw materials are defined as critical not only because they are of huge economic importance, but also because they are increasingly difficult to acquire. So far, the European Union has defined 51 raw materials as critical. And if we look at the annual consumption rates of these raw materials, we see that the Eiffel Tower is easily dwarfed by several of these raw materials, including coke, phosphate, and aluminium. Not only do we use huge amounts of these raw materials, European consumption amounts to about 10% of this total, but every year the consumption rates increases, partly due to growing human populations and economies, but also because we are in the middle of technology shifts, where the green shift and the digital revolution represents technology platforms that requires far more input of critical raw materials than the technology platforms they replace. Also, we see there are increasing challenges for mineral extraction, where declining grades, mineral grades in remaining ores provides us with larger negative environmental footprints during production. And also we see, not only in the West, but worldwide, a declining public social acceptance for such projects. We also live in a time with increasing geopolitical tensions, which disrupts not only production of critical raw materials, as we have seen in Ukraine, but also trade and supply lines for distribution of these. So this is much of the background for why the European Union launched earlier this year the Critical Raw Material Act. And one of the main goal of this act is, as Stian mentioned, to reduce the future supply risk of these critical raw materials that we cannot live without. And a main strategy in this initiative is increased focus on circular solutions. We are reminded by the waste hierarchy that not only recycling, but also waste prevention measures are important in this regard. Now, if we want our measures for higher critical raw material resource efficiency to be effective, we need to target these measures towards not only the waste streams, but also the products that we know contain these materials. And that's why we have spent some time during our work with these reports to map and describe relevant product groups and waste streams that should be considered. Today, almost all critical raw materials are supplied by linear value chains. And although we want in the future to rely more heavily on secondary products provided by recycling, this is much easier said than done. So a realistic situation in the foreseeable future is that we will have to rely on our critical raw material supply from both linear, primary and secondary value chains. If you look for strategies for waste prevention of regarding critical raw materials, circular product design is one obvious place to start. One example of measures that we describe in our report is how we can design future products in a way that makes it easier to disassemble and strip for components. This is important not only for recycling, better and more improved recycling, but also to facilitate extended repairs and upgrades that makes the extension of the product life possible. If you look at the manufacturing process, it is sometimes possible to either minimize or even substitute critical raw materials with less scarce alternatives. We have some examples that we describe in the second report. And there are also many options in the user phase. We know that critical raw materials are not only used for essential purposes like medical applications and industrial or defense. We also use large amounts for purposes that we can only describe as entertainment. So if we are looking for ways to avoid using critical raw materials, using helium for party balloons or fireworks that use strontium, barium, or magnesium as components is maybe an obvious place to start. Sharing, reusing are also ways to both prolong and effectivize the use of these products that are also described in the same reports. The Critical Raw Material Act also introduces a set of benchmarks for recycling, increased recycling of critical raw materials, and a target of 25% recycling has been set for the subgroup of critical raw materials called strategic materials within 2030. If we look at the status for European recycling of critical raw materials as of today, we can see here that for a few critical raw materials, including tungsten, copper, platinum group metals, and antimony, this 25% recycling target has already been achieved. For another around 10 other critical raw materials, we are well underway in achieving this. But for more than half of this group of critical raw materials, today's recycling is either marginal or non-existent. And that means that the challenge we face in creating secondary value chains for these critical raw materials are massive and needs to be addressed with huge efforts if we wanted them to become successful. If we look at relevant measures to facilitate increased critical raw material recycling, obviously these measures will differ regarding how mature value chains we start out with. For both critical raw materials where we have mature recycling operations like we have in the upper part of the diagram, or where the recycling operations exists but are still limited, an important measure is to improve the collection and sorting of waste that may serve as feedstock for this recycling. If we look at critical raw materials where no recycling so far exists, we should focus more on research and development efforts to develop recycling technologies that can serve as platforms for future recycling in this regard. Skipping a little bit ahead due to my time is running out. The second report in our report series focuses on how to reach these recycling benchmarks. We need to eliminate the material loss that we experience of critical raw materials during the different steps of the value chain. And the second report in our report series contains a series of measures that describe how we can both identify the waste streams that today are unexplored for recycling. We describe how collection and sorting and treatment can become better and facilitate recycling more efficiently. And we describe measures on how to improve recycling, both in terms of efficiency and regarding how to provide higher quality secondary products compared to what we are able to do today. I don't have any time to go through the last case that I wanted to present a more in-depth description of, but I will advise you to, if you want a more extensive description than what I am able to provide now, which is only a few glimpses. As Stian mentioned, you can download our first report already, and the second reports will be available at the same site, which I provided a link to in this last slide. Thank you.
Thank you, Carl. Yeah, we could probably have our own session on this forever, basically, a whole day session on critical materials. But now you have at least some teaser on what we're working on and what you can expect from the two reports coming up. We will also drag Carl up on the stage a bit later again as well. But first, we will dig a bit deeper into one of the sectors that use a lot of critical materials and where the potential to reuse and recycle is yet to be explored. We are talking about data storage service and data centers. The need for data storage is estimated to explode only in the coming years. I mean, it is already exploding. And from a circular perspective, this raises the question: what happens with all the equipment? We're now going to actually present a report that is published in its entirety. Viggo Måge has looked into this on behalf of NCE. And while there are several other materials they have considered, such as plastics, Matthias Hermann's report, presentation here will focus mostly on critical raw materials. So Matthias, please, the floor is yours.
Thank you. I'll just see if I can share my screen. One moment.
We can see the presentation now, Matthias.
Perfect. And do you see the presentation or the presentation mode?
The presentation mode we see now. You can see all your notes as well.
Mm-hmm. Let's see, how do we get this to work?
Do you want us to share from here, Matthias? We can also do that.
If possible.
Yes.
Maybe that would be better. I'm a little uncertain as how to make it share the correct screen.
Now, for all of you following us, please don't log off because this is only a native blip, and we'll go right back into it. Is it here? Yeah. So now I think that just I think. Yes, stop sharing and we'll share from here.
Mm-hmm.
Okay. Go down. More like to completely down.
I think I have it now, maybe. Yeah.
Yeah, there you go. Yeah.
Can you see my my real presentation now?
You can see.
Okay, perfect. Sorry for the delay. It's always with these technical issues. Even though I'm relatively young, I still can't figure out how it works. Well, yes, my name is Matthias, and I'm an advisor at Viggo Måge, and I was one of the authors behind this report for the NCE called Eco-Design Requirements for Circularity of Service and Data Storage Products. We started the project in 2023 and finished it earlier this year. So first, quickly, the agenda for this brief presentation. I'll start by introducing Viggo Måge, then the project, then go into some of the key findings on avoid and reduce, reuse, recycle, and then the policy options at the end. So Viggo Måge, as I said before, I'm an advisor at Viggo Måge. It's a Danish consultancy working solely with sustainability-related topics. From assisting with ESG reporting to optimizing and electrifying industrial processes. We're situated in Copenhagen, but I'm sitting in Aarhus, and we also have people in Delft, Brussels, and Seville. So the study, the aim of the study, it was to support the development of EU product policy with a focus on scarce, environmentally relevant, and critical raw materials in servers and data storage products, and then propose policy options to make circular eco-design requirements. The approach we took was to first conduct a desk study to learn from and try to synthesize some of the knowledge already available. And then we conducted a qualitative interview with selected stakeholders from the industry, which covers academia, manufacturing, recycling, refurbishment, and industry organizations. The reason that we did the study, or was asked to do the study, is that this product group has been and will continue to grow fast. They contain a lot of different raw and processed materials, many of which are on the EU list of critical raw materials. And currently the recycling rates are minimal, close to none. So starting with the key findings on avoid and reduce, where are the critical raw materials found? As you can see from the table here to the right, there's a long list of critical raw materials found in servers and data storage devices. This is the list of the compartments that contain the most. This includes the hard disk drives, the solid state drives, the printed circuit boards, batteries and connectors. The amount of critical raw materials in terms of weight is largest in the HDDs, but the number of critical raw materials is largest in the SSDs, which also includes the PCBs, printed circuit boards. It is very difficult to avoid reducing the use of critical raw materials, as they are first of all integral parts of the function of the components where they are used, and making restrictions on their use might conflict with innovation. So it's very difficult to avoid using critical raw materials in this product group. So going to reuse. One of the main topics that was brought up during interviews and in literature was secure data deletion. So first off, how is data deletion typically handled? Well, data can be deleted in different ways, both physically destroying the servers or by using data deletion software. The most widely used practice is, however, to shred the server. There was, however, one industry organization that estimated, based on member feedback, that around 80% of the time that a destructive data deletion was used, data deletion using software would be a viable option. Yeah. So the importance of secure non-destructive data deletion. There are multiple reasons. Of course, it's a necessity for reuse. But also, even if the server is to be recycled, it maintains a high economic value if it's delivered whole at the recycler rather than shredded. And it also allows for sending parts to the dedicated treatment facilities, as the recycler states here with neodymium, which is found in hard disk drives. It's crucial that the drivers are not shredded if neodymium is to be recovered. So what is keeping companies from using non-destructive data deletion? As one stakeholder pointed out, large companies are not going to use data deletion software simply because it's going to take too long to run the software on each server, and there's going to be a fear of the data deletion software not being effective enough. So it's simply just easier, cheaper, and you avoid the risk of data leaks if you just shred it rather than use software. It is also a general fear among companies that the data deletion software is not secure enough. There's always also many small companies with on-premise servers and data storage devices that are not aware of the functionality. And as they don't know exactly what to do with them, they just end up putting them in the basement. And when they get too old, they lose their resale value and they will have to be sent to recycling at the end. Also, some of the most used standards for data deletion actually prescribe that the server should be shredded if they contain sensitive data. That's also a major issue. So on recycling, the current status of critical raw material recycling, through literature and stakeholder interviews, we identified 20 different critical raw materials present in servers. Chromium, cobalt, silicon, metal, and neodymium is estimated to be present with around 10 grams per device. And one stakeholder said that from a recycling perspective, or at least from their perspective, 10 grams would be sort of their bottom limit for what they would try to extract. So most other critical raw materials are present in lower concentrations than this. The current rate of recycling of critical raw materials from servers is estimated at around 1%, and it's mainly cobalt. But literature do indicate that there are new recycling capacities being installed that might be able to recycle more critical raw materials. It is, however, uncertain how much it's going to be. It was also indicated both by literature and stakeholders that the Umicore process is the most advanced one, and it is currently able to recover 4 different critical raw materials. And as I said before, there were 20 identified in servers and data storage devices, and the most advanced one at the moment can extract 4 different ones. So the main obstacles and challenges for developing a recycling infrastructure. Well, first, the industry is evolving very fast. There's a constant innovation and low to non-existing focus on how the product is going to be handled in the end-of-life stage. There's a general lack of mass, so there's simply not enough critical raw materials in each, or of each critical raw materials, and there's not a dedicated market for the recovered critical raw materials. And the price of the critical raw materials cannot really compete with that of virgin materials. So it's hard to make a business case. Then there's the physical barriers, as one of the stakeholders also pointed out, that often the process needed to extract one material hinders the extraction of another. And that's the highest value material that often prioritized, which tends to be precious metals rather than the critical raw materials. The critical raw materials are also present only in low concentrations, as mentioned before. And there's a lot of different critical raw materials in each product, and they're often mixed in with other materials. And as stated in the beginning, there are more critical raw materials in HDDs in terms of mass than in SSDs, and thus the criticality of SSDs is generally said to be lower. However, as the concentration of each critical raw material in the solid state drives are lower and the number of critical raw materials is higher, the possibility of recycling them might actually be lower. It might be more difficult. And then the last issue is that the recyclers cannot really know for certain which critical raw materials are in the scrap they receive, or the amount of critical raw materials. And so last part, policy options, and I will try to be quick. First part is the ban part. So ban the use of critical raw materials in all other parts and electronic components, but for instance, in the chassis. As critical raw materials were found to be present in small amounts in these parts, and with potential substitutes, there might be an option to avoid the use here. Require that only a limited number of critical raw materials can be used in specific products or components. Here it might be possible to limit the number of critical raw materials used in this product group to increase the concentration and reduce the number and the variability. However, as stated earlier, this might be in conflict with innovation. Then going to standardization, it's not something that was brought up here in this presentation, but a lack of standardization between brands and generations was something that we found in the report. And here it might be possible to standardize some parts of the design so it's easier to reuse and repair. Then going to the secure data deletion, that could be a requirement on the presence of data deletion software that irreversibly destroys the data in the device. Here it's also important that the data deletion standards are updated to recommend the use of non-destructive data deletion, even for sensitive data. Then there should be an information requirement regarding the presence of the secure data deletion functionality. and it should include how it is used, the degree of security, and which data deletion standard it follows. And then in order to document that the server, the data storage device, has undergone data deletion treatment, there should be the software should be able to produce a certificate attesting that it has happened. And then for the recycling part, one thing that could be done is making an information requirement in order to make it possible for recyclers to know what is in the different scrap that they're receiving, so they know what to focus on extracting or trying to develop new technology to extract. Yeah. So that was all for me. Thank you. And I will stop my share.
Thank you so much, Matthias. Very interesting. And as with the other speakers, I wish we had more time to go even more in depth about your report, but hey, that's life. Anyway, I won't let you go just yet, and I want to ask some questions, and I also like to ask Carl to join us. We have received a question on if the material will be made available. I will check with the speaker to see if we can do that. Otherwise, of course, this is all the information is available or will be available in the reports.
Yeah.
Yeah. Just some questions to you. Can you join me here in the frame, Carl? Thank you. I mean, your report is not only on critical raw materials, Matthias, but it's such a prominent issue when it comes to data storage and data centers, right?
Mm.
And Carl, you studied them. The main topic is critical raw materials. And how important would you say that data servers and data storage centers are in this regard?
Well, although they don't represent a very large waste stream, it is a very attractive waste stream. And it may seem paradoxical because Matthias made a very good case of describing the very real challenges regarding recycling these resources. Yes, they are rich in although these products are high in critical raw materials compared to many other waste streams. They are still not high enough to make an obvious profitable case seen from a business standpoint. So my perspective here would be that if even such an attractive waste stream as this is difficult to recycle from with today's current market conditions, then it will border on wishful thinking to believe that we will make very long headway in improving our CRM recycling in the future, unless we radically change these conditions. Mm. So, but I believe data storage units could serve as a very interesting pilot case on how to not only achieve better recycling, but also develop automated processes that strip components that should be recycled separately, and also design collection systems that makes this as rational and cost effective as possible.
And I guess we can reveal that one of the measures in the report that will come up is exactly on creating an industry around recycling of PCBs.
Yeah, it's very fun to hear Matthias summarize his findings, because although we have had no contact during our work, we have actually arrived at many of the same both barriers and also what we consider to be important measures to break down these barriers.
That's also my impression. I think those two reports actually complement each other very well, because you have the critical materials overview, and then Matthias's report goes in depth on actually this topic. And Matthias, I have to ask you a question about reuse, because we had this discussion before we planned this session that recycling is maybe an easier way on many of the critical materials, and reuse much more difficult. But then you said no, when it comes to data storage servers and components, actually reuse is coming up as an option more and more, right? Or more often than the recycling. And then you spoke about the reuse of SSDs depending on data deletion, but you also have other components, other PCBs that don't really store data, right? How about those? Can they be easily reused, or what was the challenge there?
I think in terms of reusing parts that are not containing data and that doesn't have to be sanitized, the issue of reusing them is a lack of standardization. So this is also one of the parts being brought up, is that there is a possibility for standardizing different components of servers and data storage products, so they can more easily be used for different generations, and between different brands, both in order to reuse them, but also in order to repair. Yeah.
And you did involve business when writing the report. At least you had contact with them.
Mhm.
And I know that you have the workshop where you also discussed this, and standardization came up. What is the perception of the business? Are they willing to take that step? And how is the perception on circular economy in the sector in general?
I think my perception was that there's a general wish to participate, but it's not the primary focus. So things will become more circular if there's economy in it, but there's no economic incentive in changing a product just to make it easier for the recyclers to extract critical raw materials, and no incentive to create like a larger second-hand market. And then also another issue that was brought up is that typically many of the manufacturers are just buying the different parts from many different places, and then they combine them at their side. So there's also a lack of both transparency and also decision-making power to make changes on each component. You can say that. Yeah,
so you can see also here how all this issue that we're talking about today intertwine with waste prevention, to Sanna's presentation on financial measures that also will probably then be relevant for this sector, right? Just like what dropped into my head right now.
Agree.
Anyway, you've been focused, of course, on the Nordic region, being that we are a working group on the Nordic region, and I would like to challenge you both with a question. What is the single most important contribution that the Nordic region can do for improved circular approach to critical raw materials? We'll start with you, Carl.
Well, I think we've touched on it already. We need to create economic incentive for pursuing these types of business models. And there are also huge technical barriers that needs to be addressed, not only when it comes to recycling operations that today really have poor technological solutions for this, but really begs to be improved. But also when you look, as I referred to also before, collection and especially automatic sorting systems. Today we recycle a lot of waste in a mixed stream that provide us with impure secondary products of questionable quality, and also loses a lot of important critical raw material that could be recovered if we instead had separate recycling process for substreams of this stream. And we really need to focus. You mentioned, Matthias, shredding. Shredding is a cost-efficient but very resource inefficient separation technique, and we need a new generation of sorting systems that can improve this.
So basically, a better or improved or new technology for sorting.
Next, after economic incentives, technological improvements are the main concern as we see it.
Matthias, do you agree? You're nodding.
Yeah, I definitely agree with all that Carl says, and my point would also be that of course we need to have a focus on life extension methods, but that's only going to mitigate the problem. It's not going to solve like the end problem. The electronics are always going to break at some point, and we need to be able to extract the materials used. So changing this whole conception about critical raw materials recycling, because as we talked about before, there's likely not going to be a strong business case for recovering a lot of these critical raw materials, even though that the benefit on a societal level is very clear. So we should just start seeing it more as it's a service that we as a society support and pay for, both in terms of making the right legislation and funding. And then we need to establish transparency from the beginning to the end of the whole life cycle of the products. Yeah.
Interesting. Yeah, you touched on it, of course, but I will then anyway ask you, Carl, if you can pinpoint like one major barrier. I mean, is there anything you want to add what you talked about already?
Well, we talked about technical and economic barriers already, but I would also like to emphasize that Nordic and European industrial production doesn't exist in a vacuum. Europe used to be the main supplier of what we today consider critical raw materials. Before 1900, 60% of the world global production of these materials came from Europe. And then it moved to the United States, and now it is centered in Asia. So we are not only competing, also we're not only struggling to make this a business case in Europe. We also need to be economic sustainable in competition with similar production abroad.
Both reports, they highlight that when you actually do recycle some materials from these components, they extract the most valuable materials, and that's gold basically, and maybe copper. But that's not critical material. Yeah, okay. Yeah. So, but so far then, how can that change? Is that also the only question of economics, that they extract it because it's the most valuable, or how can that be changed? Is it also just a question of financial incentives and political legislation, or how can that change? I'll ask Matthias first.
Okay. Well, of course, the first part is that the recyclers need to know what is in the scrap or in the products they're receiving. So right now, there's so many different critical raw materials. They are normally present in very low amounts. And the recyclers don't really know how much there is and what there is. So just knowing what's in the products is the first step. But then even if you know what's in the products, it's probably going to be in so small amounts that there's no economy in extracting many of the critical raw materials. So I think it's, and then even if there was economy in it, then it might be that that there are 3 different critical raw materials that there would be economy in extracting, but extracting one of them would require a physical, or would require a process that would make it impossible to extract the other one or the third one. So it's just so many different barriers in terms of the recycling, and it just needs more funding and investment because there's no economic incentive for recyclers to invest in new technology when there's such an unsure market and so high like initial costs of trying to develop new technology. Yeah.
All right. Yeah, I think we'll leave it there because now you can also touch on other things like eco-design requirements, right, for both recycling and reuse and digital passports, Matthias. That's then also, if you have digital passport, maybe some of these issues that you raised now can be solved about, recycling, knowing what's in the different components. But then we start opening up a whole new field of discussion. So I think we'll leave it there. I will say thank you to Carl and Matthias. And I will, we haven't received any more questions. So I will then thank everyone who followed us today. And I will again remind you that our reports can be found, the one that we have produced can be found on our website. And the ones coming up will be also published on norden.org and will be also highlighted on our LinkedIn site. So thank you for everyone following us today, and have a good afternoon.